discussion. Today we are going to discuss about the design thinking approach, which is based on half adder. As a design thinking, as SNS institution, we are following the design thinking approach, which is having the 5 stages: empathy part, and ideate, define, and prototype, and test part. In the 5 stages, take the half adder problem, and you can discuss it briefly in 5 stages. In the half adder, which will be based on combination circuits. We know the combination circuit is nothing but is one of the digital logic circuit, which will be having the output which is not based upon the past inputs. And coming to the classification of combination circuits, it will be classified into 3 types. The first one will be arithmetic operation, will be followed in combinational, and second one will be data transmission, and third one will be code converters. And coming to the first classification part, arithmetic, where we will be having adder circuit, subtractor, and comparator circuit will be there. And second one will be the data transmission, which will be having multiplier circuit, demultiplier circuit, and third one will be the converter circuit, which will be having binary converters and 7-segment converters will be there. Now we are going to discuss about briefly in the half adder circuit. In each stages you can explain that in detail. And the half adder is nothing but which will be having 2 input and 2 output, and it will be elaborated in truth table, K-map, and logic diagram will be illustrated. At last, we are going to discuss about the application related to the half adder.
So here's the empathy part. In design thinking, empathy means stepping into the shoes of the people who will get benefit from the solution. For combinational circuit, the users are not just people, they are engineers, students, and systems that rely on binary addition. Even the most complex circuits like CPUs and calculators, it starts from the simple operations like adding of 2 bits. Without a reliable way to adding 2 binary numbers, it is not possible to further go with any other operations like subtraction, multiplication, and encryption, signal processing like that. And students and learners needed a simple and clear circuit that will make them understand the foundation of the logic gates, and engineers need a building blocks that can scale up into more complex circuits. Using too many logic gates can waste power and space in the chip, and beginners find it hard to connect with abstract math and with physical logic gates.
In this defined part, we can take a particular problem. We need to design a problem that can have 2 inputs and we needed 2 outputs. So we can take a half adder solution. Based on the mathematical expressions, there are a lot of circuits, combination circuits such as adder, subtractor, and multiplexer, demultiplexer. Here we choose half adder because in the need of the input, there are only 2 inputs needed. So for the output also we can derive this 2. So in case of 3, when the 3 inputs are needed, we can shift to the next full adder circuit. In case of multiple operation such as more than 4 bits or 5 bits, we can use a combination circuit such as both half adder and full adder. So here actually our problem is to design a circuit to have an input. So we choose a 2 adder circuit for better implementation. For our problem statement, the general users are like engineers. They are using simple operations such as binary addition and subtraction, so that we can choose only low performance to half adder the operation. In case of need of any differential users, we can choose the full adder circuit.
ID. Consider the 2 binary inputs A and B, and form a truth table and analyze the input and get the output as sum and carry. From the truth table, analyze that the sum output as the XOR function and the carry output as the AND function, and implement the case in a minimum way as per the only one XOR function for sum and only AND function for AND gates. Ensure that the designs are made using only NAND or only NOT, that is universal gates.
So now we are going to see about the prototype. Since we are discussing about the half adder, which consists of since it is a combinational circuit, it is a combination of both the XOR and AND gate, where we will derive it from 3 steps. The first one will be the truth table, where we will get the output for the desired input which will be included the sum and carry. By using the sum and carry, we will go for the second step, which will be plotting the Karnaugh map. Since we are talking about the half-adder combinational circuit, we will use only the two variable Karnaugh map. By using that, we will from by the sum we will get the logic diagram as XOR gate, and by using the carry we will get the logic gate as AND. The combination of both an XOR and AND will be called as the half-adder combinational circuit. We can implement this in real life by using the tester kit, where it consists of a breadboard, and by using the two IC, which is 7408 and 7486, which is both XOR and AND gate. By using this, by getting the output in the form of LED indications, and after the testing and validation process, it is used in for a wide range of applications, such as in ALU, which is called as arithmetic logic units, and other calculations and other microprocessors, etc.
Okay, thank you. Thank you for the discussion.
Thank you.